Today we will learn the last two methods for solving quadratic equations. Let's refresh by solving this equation. If I'm going to factor, I want it to be in standard form and equal to 0. Because a is not equal to 1, we're going to need to use double cross or whatever method you prefer. And yeah, you may have noticed that this term is a perfect square, that 25 is a perfect square. Then we have the correct factors. You could use zero product property to solve. Or you could use square root property of equality. So the answer is plus or minus 0, but there is no positive or negative 0, so just 0. And solve for x. So you may have noticed that this right here was a perfect square trinomial. And a perfect square trinomial is really convenient because it factors to be a quantity squared. If you have any product that equals 0, you can just use zero product property. But in order to use square root property of equality, you don't have to have 0 on the other side, which opens up more possibilities. So being able to turn something into a perfect square trinomial and factor it in order to use square root property of equality can really help when solving quadratic equations. This method is called completing the square because you're not given a perfect square trinomial, but you will need to algebraically manipulate the equation so that you have a perfect square trinomial and then factor it to use square root property of equality. Completing the square works on every quadratic equation, but it gets much more complicated when a is not equal to 1 and somewhat more complicated when b is an odd number. So my recommendation for when a quadratic equation is a good candidate for completing the square is when a is equal to 1 and ideally when b is even. Your steps for completing the square will be to move c to the other side of the equation. So not to get it equal to 0, we want to separate the x terms from our constant c. Then we're going to turn the x terms into a perfect square trinomial by adding the correct value to that side of the equation. If you add something to one side of the equation, you have to add it to both sides. Then we'll factor and use square root property of equality. And then we have this formula, the quadratic formula, which works for every single quadratic equation. So you may be wondering, why did we learn all the other methods and can I just use the quadratic formula each time? The test is going to require you to use every single method at least one time. So you're going to need to differentiate when is the right time to factor, to square root, to complete the square, or do I need to use the quadratic formula? The a, b, and c in our quadratic formula comes from standard form ax squared plus bx plus c equals 0. It must be in this form in order for you to use the quadratic formula. Lots of people have a song for the quadratic formula. I have a particular song and we're going to sing it in class tomorrow. But just to get you ready for that, here it goes. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. For our examples, we're going to solve the following by completing the square or quadratic formula. So let's determine if this is a good candidate for completing the square, and if not, then we'll use quadratic formula. Number 1, a is equal to 1 and b is even. So this is a great candidate for completing the square. And they told us to solve it by completing the square or quadratic formula, so we will complete the square. X squared plus 18x plus 25 is not a perfect square trinomial because it does not follow the form a squared plus 2ab plus b squared. So I'm going to keep the x squared and the x term on the left side, but move all constants over to the right side. Now we've made space for a new c, and this new c is going to complete this into being a perfect square trinomial. How do we determine what that number should be? That number is b divided by 2 squared. Remember, b is 18, so 18 divided by 2 squared is our new c. Add that to the left side of the equation to complete the perfect square trinomial, and if you add it to the left side, then you have to add it to the right side. Now it's time to factor our perfect square trinomial. Remember the pattern for a perfect square trinomial and how it factors? X times x would give me x squared. 9 times 9 would give me 81. And because it's a positive 18, this needs to be plus 9 and plus 9. And you can always check by multiplying. Now write your factored form as a quantity squared. And use square root property of equality to solve. That's plus or minus root 59. 59 does not have any perfect square factors or any factors at all, so we can't simplify that radical. Isolate x, and you have your solutions. Negative 9 plus root 59, negative 9 minus root 59. For number 2, determine a and b. A is equal to 5, but b is not negative 5 because this is not in standard form. So let's put it in standard form so we know for sure what b is. B is positive 5. Usually we would attempt to factor first, but again, our instructions told us to use complete the square or quadratic formula. This is not a good candidate for completing the square because a is not 1, so let's use the quadratic formula. I already know a and b, let's find c and plug it into our formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now simplify. Now you may be tempted to want to reduce 5 over 10, but you cannot reduce unless all 3 terms have a common factor. I know 135 has a factor of 5, but this is not 135. This is root 135, or root negative 135. So first, simplify the radical. 25 looks like it might go into 135, but no, it does not. What about 16? No, try 9. 9 goes into 135. Now I would be able to reduce this if this number also had a common factor with 5 and 10. But no, it does not, so I'm done. Here are my 2 answers. For number 3, a is equal to 1 and b is equal to 20. Looks like a good candidate for completing the square to me. First, isolate your m terms by moving all the constants to the other side. Now you've made space for a new c, the c that will complete this to be a perfect square trinomial. That c value is b divided by 2 squared. Since b is 20, c should be 100. Add 100 to both sides. Because the left side is now a perfect square trinomial, we can factor it. The number that goes here is always b divided by 2. Now use square root property of equality to solve. Simplify this radical. The largest perfect square that goes into this is 4. And we have our solutions. Now for number 4, a is equal to 2 and b is going to equal negative 4 when we're in standard form. So yeah, this is a good candidate for quadratic formula. Put it in standard form and then plug it into the formula. Remember, the opposite of b is just changing the sign. So since b is negative, now the opposite of b will be positive. Any number squared should be positive. Root negative 8 can be simplified. And our last step is to reduce if possible. Do these three terms have a common factor? Yes, 2 goes into 4 and 2. So go ahead and divide each term by 2 or factor out a 2 and reduce. And now your answer is fully reduced. If you do not reduce, you will not get full credit. Even if you prefer to use one method over the other, you will be assessed on using every single method. You must be comfortable with each method and determining which method works best on which problems.